Did you know that one forgotten detail in your code can cause a worldwide pandemic? Imagine this. A bustling world suddenly thrown into chaos as a mysterious plague called corrupted blood sweeps through the streets. The trouble started when Blizzard, the company behind the game World of Warcraft, introduced a new boss, Hakar the Soul Flayer. Hakar the Soul Flayer had a new and devastating spell called Corrupted Blood. This spell could spread between players, but it was designed to be confined to Hakar's dungeon. Think that worked? Let's find out! There was one thing, however, that the developers didn't take into account. Pets. Players could have pets. Pets could be infected. The infection did not leave the pets when they left Hakar's dungeon, and like that, the disease spread into the broader world. Lower level players died instantly. NPCs became asymptomatic carriers as they couldn't die from the disease, but they could spread it. Quarantines and server resets didn't work. The plague spread uncontrollably. If a single overlooked bug can cause this kind of havoc, imagine what it can do in your code. And that brings us to the topic of today's video: 3 steps that will squash any software bug. The palette of software bugs is broad and colorful. We have the beloved null pointer exception, logical errors in your code, and my favorite grievance, failure to validate input data. But what's your favorite bug? Let us know down in the comments. You're skeptical. Can we really fix any software bug following just the same steps? Well, yes, of course. Why else would I even bother to make this video? So let's polish your code to perfection by following these 3 simple steps. And as always, I have a smoking hot super tip for you towards the end of the video. Step number 1, debug to reproduce. Why is reproducing a bug so important? Well, if you cannot reproduce the bug, how are you going to fix it? The bug that's being reported might not be a bug at all. It could simply be the end user misunderstanding how the software is working. And by the way, if you are tired of receiving poorly written bug reports, the answer to that comes in a smoking hot tip at the end of the video. How do you go about reproducing a bug? Well, that's easy, isn't it? You just do like everybody else. You find the area in the code where you think the bug is, and you start outputting variables to the console. That's how you do it, right? Right? No! Your IDE is your best friend in debugging. And maybe your best friend in life in general. I don't know your social life. I'm not judging. But with the IDE, you can set breakpoints, you can step through code line by line, and you can view the contents of variables as your code executes. We need to illustrate this with an example. What you see here is a very simple Java function called isIPaddress that returns true if the inputted string is a valid IP address. Now, we've had some trouble with this function throwing an exception, so we decide to set a breakpoint at the start of the function. We then start the application in debug mode, and when this function is called, execution will stop. We can then use these little buttons down here and step through execution line by line, while at the same time we can see the contents of every variable. It becomes immediately obvious that this function cannot handle the parameter IP being null. Fantastic! Now all that remains is to fix the bug, right? I pity the fool. You've now reached step 2, which is write an automated test. The automated test will of course fail, thereby reproducing and proving the bug. Now this calls for a sexy example. We are back again at our isIPAddress function, and we have already established that this function doesn't handle null very well. So what to do? Easy. We write in an automated test that sends null to this function. And with a little bit of cheating, here we go. We have a JUnit test that is testing the function isIPAddress with the parameter IP null, and we assume that the function will return false as a result, meaning that null does not evaluate to a valid IP address. Now our next step is to run this test, and as you will see, the test is failing. We are not getting the result that we wanted, and we have proven that the bug is real. Thank you, Studio Me, and welcome back to Outdoor Studio Me. Why do we write automated tests? Now, the topic of writing automated tests is too broad to include in this video, but I plan to make a whole series about this in the future, so squeeze that like and subscribe button as if you're terrified of reintroducing the bug you just wrote in a future release. Reintroducing a bug that you've already fixed, you said? This is sadly an all too familiar story. You've just fixed a very complicated bug. The mood in the office is ecstatic. The customer loves you. The champagne flows freely, only for it all to come down crashing and burning a few months later as the bug is reintroduced into the code. If only there was a simple way of preventing reintroducing bugs. I met a guy once who thought automated tests were a waste of time. He was also a flat earther. There is no better way to ensure the quality of our software than writing automated tests. Let's recap. You have reproduced a bug. You have written a test that fails, proving that the bug is there. You are now in control. Chances are pretty high that during this process, you've already figured out exactly how to fix the bug. Actually, most of the time fixing a bug isn't spent fixing a bug at all. It is spent reproducing the bug. Here, take a look at this pie chart illustrating how time is spent fixing bugs. So now that you're 95% done, take a break. You spend a lot of mental energy trying to get this bug under control, and we software developers work better if we take regular breaks. Every software developer I have met have the story of the bug they tried to crack at the end of their workday and just couldn't figure out, but which they spent 5 minutes the next morning resolving easily. This shows the importance of taking breaks. So get away from your screen. Go talk to a colleague, call your mom, get outside, get some sun, feel the grass between your toes, lay down, look at the clouds, have a conversation with a squirrel. What have we learned today? Well, the 3 steps that will squash any software bug are: number 1, debug to reproduce. Use your IDE and the powers it has to help you reproducing the bug. Once the bug has been reproduced, step 2, write an automated test. This automated test will of course fail, proving that you have a bug and making sure that you will not introduce this bug in a future release. And when you're done, move on to step number 3, which is taking a break. I promised you a smoking hot tip in the end, and this is one we can all relate to: poorly written bug descriptions. I lost most of my hair over nonsensical bug descriptions that I couldn't use to reproduce anything. How do we resolve this conundrum? Easy. We simply just don't fix the bug. We send the poorly written bug description back to whomever wrote it with the instructions, please provide better reproduction steps. And if what you get back is still not good enough, well, You'll teach them a real-life example of recursion. Bug fixing isn't glamorous, but it is an important part of our job. And by using these simple 3 steps, you can become more efficient in bug fixing and eventually make your code great again.